champions, your PU2 physics board examination is just 2 days away and numericals are sure shot questions in your examination, so you should definitely master them. So in this video, I will be discussing the most important numericals chapter wise. So let's get started and first see which are those chapters from which the 5 marker numericals will be asked. So the first chapter is here electric charges and fields or electrostatic potential and capacitance. So from any one of these chapter, the first numerical will be asked. The second one is current electricity, third is alternating current, and fourth one is either from wave optics and ray optics, but most probably it will be from ray optics. There's a high chance that the question will be from ray optics. So now if you see, there is an option here, we are not sure from which chapter it will be asked. Here also there is a slight dilemma, but these two are the chapters from where definitely one numerical will be asked. So we are going to discuss from all these chapters the most important numericals. I will also be giving you the final answer so that after you solve, you can check whether you have done it correct or not. Now, before moving ahead, there is something very important. So KCET 2026 examination is around the corner, and if you really want to crack this examination, then only studying will not help you. You need to write tests, practice, you need to understand the exam conditions, exam pressure, and for that you need a good test series. So to help you with this, I have launched the Fighter KCET 2026 test series, which is based on KCET exam pattern and syllabus and is designed by KCET experts. So here we have total 18 full-length mock tests, 6 each from physics, chemistry and maths, and you will get detailed solutions, video solutions for chemistry, and most importantly a detailed analysis report to understand your weak and strength areas. So the most interesting part here is all these things are available at a very affordable price of just rupees 399. The link is there in the description section. You can purchase it right now as the prices may go higher later. Okay, so now let's start with our first chapter, that is electric charges and fields. So let's see its questions. So the first question is like this: 3 point charges of plus 3 nanocoulomb, minus 3 and plus 2 are placed at the corner of an equilateral triangle ABC of side 0.3 meter in air. Find the resultant force acting on plus 2 nanocoulomb. Okay, answer you will find is this one. Now next question is on the square shape, like that. 4 point charges like 2 microcoulomb, minus 5 plus 2 and minus 5 are placed at the corners of the square ABCD of side 10 centimeter. Find the force on 1 coulomb charge placed at the center of the square. Next, 2 point charges 10 microcoulomb and 20 microcoulomb are placed at the corner of the hypotenuse BC of a right angle triangle ABC of side AB equal to 3 centimeter and AC equal to 3 centimeter. Calculate the resultant electric field at point A. Next, we have 3 charges equal to 4 nanocoulomb are placed at 3 corners of a square of side 2 centimeter. Find the resultant electric field at 4th corner. Next, we'll see question number 5. 4 charges of 4 coulomb, minus 3 plus 2 and plus 3 are placed at the corner of a square of side 1 meter. Find the electric field at the center of the square and also the direction. Next, 2 point charges 5 and minus 5 microcoulomb are located at A and B respectively and separated by 0.2 meter in vacuum. What is the electric field at the midpoint O of the line joining two charges? If a negative test charge of magnitude 2 nanocoulomb is placed at point O, then what is the force experienced by it? Next, 2 point charges 5 nanocoulomb and 20 nanocoulomb are separated by a distance of 2 meter. Find a point on the line joining where the electric field is 0. Next, an uniformly charged spherical shell of radius 10 centimeter has a surface charge density of 16 microcentimeter square. Find the electric field due to the shell at a distance of 20 centimeter from the center of the shell and 5 centimeter from the center of the shell. Now, this question was asked in March 2025 as well. Now we will see the second chapter, that is electrostatic potential and capacitance. So the first question is: 2 charges of this much coulomb and this much coulomb are located 16 centimeter apart. Find the position along the line joining the two charges at which the electric potential is 0. Next, charges of 2 nanocoulomb, 4 and 8 nanocoulomb are placed at the corners A, B, C respectively of a square of side 0.2 meter. Calculate the work done to transfer a charge of plus 2 nanocoulomb from the corner D to the center of the square. Next, we have question number 3. An 800 picofarad capacitor is charged by a 100-volt battery. How much energy is stored by the capacitor? The capacitor is disconnected from the battery and is connected to another 800 PF capacitor. What is the electrostatic energy of the system? Next, we have two capacitors of capacitance 2 microfarad and 8 microfarad are connected in series, and the resulting combination is connected across a 300-volt battery. Calculate the charge potential difference and the energy stored in each capacitor. Now you can see every answer is given here. Moving to the next one, in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power of minus 3 meters square, and the distance between the plates is 3 millimeter. If the charge on each plate is 1.8 into 10 to the power of minus 9 coulomb, find the capacitance and the energy stored in the capacitor. Next, we'll see question number 6. ABCD is a square of side 2 meter. Charges of 5 nanocoulomb, 10 and minus 5 nanocoulomb are placed at A, B and C respectively. What is the work done in transferring a charge of 5 microcoulomb from D to the point of intersection of the diagonals, that is to the center of the square? Next, in a parallel plate capacitor with the air between the plates, each plate has an area of 8 into 10 to the power of minus 3 meters square and the distance is 2 millimeter. Calculate the capacitance of the capacitor. If this capacitor is connected to a 50 volt supply, then what is the charge on each plate? Okay. Next, we have question number 8. The plates of a parallel plate capacitor have an area of 100 centimeters square each and is separated by 3 mm. The capacitor is charged by connecting it to a 400 volt supply. Now calculate the electrostatic energy stored in the capacitor. If a dielectric constant 2.5 is introduced between the two plates, find the electrostatic energy stored and also change in the energy stored. Next, we have when two capacitors are connected in series and connected across a 4 kV line, the energy stored in the system is 8 joule. The same capacitors, if connected in parallel across the same line, the energy stored is 30 joule. Then find the individual capacitances. Now we'll move to third chapter, that is current electricity. So when two identical cells, each of 15 volt, either connected in series or connected in parallel across an external resistance of 5 ohm, produce the same current through the resistor. Calculate the value of internal resistance and the current through the external resistor in either case. Next, we have two cells of, this was last year paper question. Now two cells of 8 volt 1 ohm and 10 volt 2 ohm are connected in parallel such that they send current in the same direction through an external resistance of 20 ohm. Find the current and the potential difference across 20 ohm. Next, two identical cells either connected in series or in parallel give the same value of current 0.5 ampere through an external resistor of resistance 2 ohm. Find the EMF and the internal resistance of each cell. Now here we have question number 4, find the current through the galvanometer. So this is the diagram given. From this diagram you have to find the current. Now next one, the resistance of the platinum wire of the platinum resistance of thermometer at ice point is 5 ohm and at steam point is 5.23 ohm. When the thermometer is inserted in a hot bath and the resistance of platinum wire is 5.795 ohm, calculate the temperature of the hot bath. Now question number 6 here, a copper wire has 3 into 10 to the power of 22 free electrons in 0.021 meter length. The drift velocity of the electrons is found to be 2 into 10 to the power of 5 meter per second. How many electrons would pass through a given cross sectional of the wire in 1 second? Now copper wire has a diameter of 0.5 mm and resistivity of this much. What will be the length of the wire to make the resistance 2 ohm? Now how much does the resistance change if the diameter is doubled? Next, we have question number 8. A battery of 6 volt gives a current of 2 ampere when connected to a resistance of 2 ohm. What is the internal resistance, terminal potential difference and lost voltage in the battery? Now we'll see the model question paper numericals from this particular chapter. So model question paper question number 43, model question paper 2 question number 43, and if you see model question paper 3 question number 43 is from current electricity. Okay, so I'll just tell you the question once again. So here in model question paper 1, the terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the new terminal potential difference becomes 2.7 volt. Now find the EMF and the internal resistance of the cell. Next, on a copper wire of length 50 cm and diameter 1 mm carries the current of 3 ampere. The number of density of free electrons in the copper is 8.5 into 10 to the power of 28 meter inverse cube. Next, you have to calculate current density, drift velocity and the time taken for the electrons to drift from one end to the other end. Now here this is a diagram. You have to calculate the power dissipated in the 10 ohm resistor that is at the center. Next, we'll move to the, I can say, next chapter, that is alternating current. So here the first question is a resistance of 50 ohm, inductance of 10 mAh and capacitance of 20 microfarad are connected in series to a 220 volt and 50 Hz AC source. Calculate the impedance, current, power factor, phase, and does current lead or lag voltage. Next, we have an inductor and bulb. one second, are connected in series to an AC source of 220 volt and 50 Hz. A current of 11 ampere flows in the circuit and the phase angle between the voltage and the current is pi by 4 radian. Now calculate the impedance and the inductance of the circuit. Next, we have a 0.11 millifarad capacitor and a resistor are connected in series across a 200 volt and 60 Hz AC source. Calculate the current in the circuit, the phase angle between the current and the supply voltage, and the power loss in the circuit. Next, we have a current of 0.5 ampere flows through a coil when a DC voltage of 50 volt is applied. A current of 0.5 ampere again flows through the coil when a AC voltage of 100 volt 50 Hz is applied to the coil. Find the resistance, impedance, and the inductance of the coil. Next, we'll see the PYQs March 2024 first examination. A sinusoidal voltage of 250 volt and frequency 50 Hz is applied to a series LCR circuit, and you have to calculate the impedance and the power factor. Then March 2024 examination 2, similar question, sinusoidal voltage of RMS value of 10 volt and frequency 50 Hz is applied to an LR circuit. Next, we have examination 3 also. The LCR circuit was asked, and you have to find out here the frequency at which the resonance occurs and the value of current at resonance. Now, if you see model question number 144, model question paper 244, and model question paper 3, question number 44, you can check. These are the questions from the chapter alternating current. Now we will move to ray optics question. A parallel beam of light is incident on one face of an equilateral prism. By rotating the prism, the angle of minimum deviation is measured to be 40 degree. Determine the refractive index of the material of the prism. If the prism is immersed completely in water, calculate the new angle of minimum deviation. Next, a ray of light passes through an equilateral glass prism such that the refracted ray inside the prism is parallel to the base. Calculate the angle of deviation and the speed of light. Next, an object is placed at the bottom of a slab made up of transparent material of Ri 1.5. The object is viewed normally from the top where it appears to be raised by 20 mm. Now find the height of the slab. Next, question number 4, a convex lens when placed in air has a focal length of 0.4 meter and the refractive index is 1.5. Now what will be the focal length when immersed in water of Ri 4 by 3? Next, two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination. Calculate the power of two lenses and combination. Next, we have a small bulb is placed at the bottom of a tank containing water to a depth of 80 cm. Now, what is the radius of the circular surface of water through which the light emerges out? The refractive index is 1.33 here. The radii of curvature of two surfaces of a convex lens is 0.2 meter and 0.22 meter. Find the focal length of the lens if the refractive index of the material is 1.5. Also find the change in focal length if it is immersed in water of refractive index 1.33. Next, we have double convex lenses to be manufactured from a glass of refractive index of 1.52 with both faces of same radius of curvature. What is the radius of curvature required if the focal length is 25 cm? What will be the new focal length when the lens is immersed in water of refractive index 1.33? Next, an object of height 3 cm is placed in 14 cm in front of a concave lens of focal length 21 cm. Find the nature size of the image. Next, we have a prism of angle 60 degree produces a minimum deviation of 40 degree. What is refractive index, and can calculate the angle of incidence. Next, if you see model question paper 1, question number 45, and in model question paper 2, question number 45 are from ray optics. In model question paper 3, the numerical is from the wave optics. Okay, so now if you see, we will move to the questions from the chapter that is wave optics. I'll just write here. These are the numericals from wave optics. Okay, so the first one is, one second, a beam of light consisting of two wavelengths of 4200 angstrom and 5600 angstrom is used to obtain interference ranges. In Young's double slit experiment, distance between the slits is 0.3 mm and the distance between the slit and the screen is 1.5 meter. Compute the least distance at the point from where the central maximum where the bright fringes due to both the wavelengths coincide. Next, in Young's double slit experiment, the distance between the slit is 0.5 mm and when the screen is kept at a distance of 100 cm from the slits, the distance of the ninth bright fringe from the central fringe is 8.835 mm. Next, find the wavelength of light used. Next, in a Young's double slit experiment, the slits are separated by 0.3 mm and the screen is displayed at a distance of 1 meter. From the slit, the distance between the first dark fringe and the fourth bright fringe is 0.6 cm. Calculate the wavelength of the light used. Okay, this is the same question. So next one, in a Young's double slit experiment, distance between the slit is 0.3 mm and the screen is kept at a distance of 1.2 meter from the slit. If the wavelength of light uses 600 nanometer, find the position of the fifth bright fringe and the third dark fringe. Okay, so now that is there. So students, now if you also want to practice the most important questions from all other chapters as well, so I have recently completed this 21 days challenge where I have given you the most important questions, which include 2 marker, 3 marker, 5 marker, numericals, everything from every chapter. So that playlist is created and you can see in my channel, and I'll be also giving you the link of this playlist in the description section. Now moving ahead, I have already created 2 videos for your exam. The first one is the last 2 days strategy, and the second one is the most important derivations. So derivations and numericals are something which you should definitely master and go to the exam, because this alone can give you 25 marks, so do not miss it. So please check this video for the most important derivations. Now, as I already told you, KCET examination cannot be cracked with a good rank without a test series. So Fighter KCET test series is already live. You can purchase it at just rupees 399, and the link for this is available in the description section. Okay, so children, this is all about in this video. So I have discussed the most important numericals, and again I'll tell you to focus on only two chapters and practice its numerical thoroughly. That would be my suggestion, would be alternating current and current electricity. And if you are more comfortable, you can also go for ray optics. Okay, so that's all, and if you have any other requirements, do let me know in the comment section, and study hard. All the best.